right? So the way it generates the, like when I go in SSL and create the private key and the public key, when I went into domain one, I did not see those. So I had to redo it. I had to recreate the certificate. Is that normal?
Yeah, that's normal because so once you create the certificate in default domain, that will be available to other domains.
Okay.
Create a certificate into particular domain, it will be only for that particular domain.
I see. Because when I went here, you see how I have Anoop domain one. So I had to create a new one called Anoop domain one.
Normal behavior.
Normal. Okay. So that was my question number one. The question number two was um, okay, so let me show you. So I go into the profile, sorry, the policy,
Mm.
and in the policy,
The XSLT you won't see it, right?
right. So I had to create another XSLT called pass through domain one because the
You
path
don't need
was
to
different.
create the domain pass through domain one. You can re-upload the same. It's a totally different domain file directory.
Right, but remember how in this case my domain one has a new firewall. You see that loopback. I had to create a new loopback, so the port number of that loopback was different.
Yes, you have to change it here. Yes, right.
Yeah, so that's why I cloned that pass through and
Okay.
I created a new sort of I mean
Okay.
same thing, just change the firewall to the new pointing to the new loopback.
Yes,
Right.
right. You are right. Yeah.
Right? So that was the case. The other, see, that's why you see here, if I click on this one,
Mm-hmm.
there is a pass through domain one.xsl, right?
Okay.
The question I wanted to ask, when I see how when I assign XSL to the transform action,
Mm-hmm.
the first time I create this output DP var is automatically created for me. Is that normal?
Yes,
Or
it's
do you?
normal.
Okay. Because when I did not type anything in, I just did a done. And when I went back in, the DP var variable was automatically created for me.
Because its data power reads the XSLT and it assumes that you are assigning something on DP variable. So
Okay.
it's creating a DP variable.
I see. Okay. Because that's why I was a little confused why it did that. Okay. The other question is so yeah, so I created this thing, then I added the root action, and then after that the result action, right? So in the root action, it's the variable context backend URL, and then assign the variable coming from here in the root action, and then in the result I gave the input as the result, and
Mm-hmm.
then go from there, right?
Yes, right.
Now the way I understood, and I did little bit of googling because I was confused between the root
Mm-hmm.
action and the result action. The way I understand is the root action just assigns the what do you call, if the way the Google told me that if the firewall is, oh sorry, if the XML firewall is a dynamic backend, then you use a variable to route the message, uh,
Yes.
right? And the root action only assigns the
Mm.
backend URL based on the variable.
Need to route where it need to route. The
Uh,
actual result action will route it.
But yeah, that's right. So that's where I was confused. I said, if this is doing everything, why even we have the result? But
Mhm.
the way it explained is that result is actually routed. This is where the physical routing is happening, right?
Yes, right.
Okay. So I was confused between route and result, right?
Okay. Yes. Yes.
Okay. So that's how I understood. The other thing I wanted to ask you is the filter one. So in the encrypt. Now this one I just looked at the how it was done, but I wanted to ask you. So this one does the matching,
Mm-hmm.
right? So that means the message comes into the pipe, and then the filtered so here's my question. So the input here, it says input.
Yes.
but the output is encrypted input. So means that's the output. So if the message is being so if if a bad message comes in,
Mm-hmm.
is this action going to reject that message?
No, it's only encrypt what based on the certificate. That's all. It
Oh,
don't validate anything. Bad message, something else. What do you mean
okay.
by bad message? Can you
Oh, so
explain?
no, sorry. I wanted to know. I think I asked you the wrong question. It's the filter. Sorry, this message. That piece, I think I got it. The filter message. In the filter message, if you look at the filter message, there there is no. Okay, I don't know why it's not coming. It's loading. Okay, so in the filter message, there is no output.
Yes.
There is only input.
Yes.
And the next so the message comes into the pipe,
Yes.
and then it hits the filter. There is no output going to the XSL.
No. Yes. Because it's just.
So
Yes.
in other words, if the bad message comes in, this guy rejects it.
Yes.
But if a good one comes, then it jumps from, because there is input to the XSL,
Yes.
right? So that piece I was little, I don't know why this is coming. Altova.
No. No. You're right. Click it. I think.
Oh, okay. So stupid, this thing, Altova. Yeah. So the message comes in, and then if there is no output, how do we ensure that the message goes from the filter to the next level? Maybe it doesn't, right? It just stops here.
Because if the message is once the message is blocked, it won't go to next step.
Okay.
Once the message is passed, then only it goes to next step. That's what the rule.
Okay, so that means the filter, so it's like a bypass, right?
Yeah.
So really the message comes from the client, and then if it's a good, it just jumps straight to the XSL,
Yes.
and then keep going like
Yeah.
that. Bit confusing though. Do you get my point, right? What I'm trying to.
Right, I got it. But basically, don't put more things here.
Okay.
But basically, what it's doing, it's validate the message which is having any SQL injection. It's a
Okay.
if-else condition.
Okay.
If then reject it.
Okay.
Else, just pass it.
Pass it to the next stage.
Yeah.
Okay. Okay.
So
And
when
that's
you pass
yeah.
it, you don't need to explicitly tell what is the message type because you're just passing whatever you're getting.
Okay. So that's where the input comes into the next level.
Yes.
Okay. And then it keeps on going. The rest of the story is the same.
Yes.
Yeah. So I can show you if I'll test it in the, I believe I still have the URLs. Yeah, I do. So I can go to domain one request. That's an HTTP. Uh, So let me take this one. So this is our first HTTP. Sorry, the
HTTP.
first,
Yes.
yeah. So I'm gonna first remove HTTP and issue it. I get a connection reset.
Yeah.
Then I put HTTPS. This is my new firewall, and I issued it. See, it's different when you do it because then I'm just following it. But when I do it, I have to think a lot, right? Then that's when the fundamentals are clear. Until like you said, until you do it, it's hard, right? So yeah, the message comes back.
But this is not the expected behavior. You are not setting the rules correct, right?
uh,
For the whole URI is correct, it has to respond you from the server. Or it's responding you from the Oh, for everything you applied a pass-through URL, pass-through XSLT.
I think, let me check, please. So, no, I think you're right. I did the, so for everything else rule,
The default request. Go to the,
it's star.
no, go to the slash. Oh, you don't apply the condition, whether slash, whether ASMX.
No, there is,
What is the XSLT applied here? Oh, this is not the pass-through. This is, should be something else.
it should be the backend one, right?
Backend on, yeah. That's
But
okay.
yeah,
But it's expected behavior.
yeah,
If you upload the backend, then it should be you can correct it now actually. Double click.
Okay, so if I double click, then I
Go and
change it.
upload. Oh, okay, backend. Yeah, backend.
Done.
Even you no need to create the dummy firewall, which is already available in the domain too, right?
Dummy. Oh, okay. Okay, so it will find even, okay, so port number, right?
Only the matter of the IP and port, right?
Right, right. I just made it consistent, so
Okay.
just that way I know what the dummy is. But you're right, I could just send it to the same firewall on that domain, right?
Yeah.
Okay. So let me try now. If I hit it, I find when I do make some change and send the first request, it takes time. The subsequent requests are fast. Is that normal? Like,
Yeah.
right?
So
Okay.
it will be cast in the data
Oh,
per side.
oh, okay. So now it came back, right? So this is the real one. So if I change it to, let's say, some this one and then send it.
Even that zip code will be available. 5-digit zip code.
Oh, okay. So it's available. So let me put
Make
some
it 6-digit or put some character.
garbage, right? So something here.
Yes.
Okay, city, but it's fast. You see, I mean, it's really fast. The first time it's little slow.
Yeah, first time the data power will make sure everything is. It will take some time to cast it.
Yeah.
Second time it's everything's available in the cast, so don't do it. Like first time, what's happening? Your XSLT transformation will be executed, and routing action will be executed. The second time you again call it. It's
Okay.
not executed once or available in the cache. It
Right.
won't
Right.
do it again. It just until otherwise the XSLT changes, or until otherwise it's flushed, or until otherwise the time exceed for the
Right.
cache.
Right. Right. So the request, the encrypt request. So this one is the reverse, I think.
Okay,
Oh,
try
this
to
is the
decrypt.
decrypt. Yep.
Okay, I got it. Try to decrypt. That's fine. That's fine. Try to decrypt. Let's see.
Okay.
So what is the problem you see here? Can you tell me?
Um, I decrypted this from yesterday. I mean, the message was,
Yeah, you encrypted this message yesterday or from long time back,
yeah,
but still you can able to decrypt, right?
right.
So that's what normally people doing encrypt message. They will set the expiration time on the message.
Oh, okay.
For example, 5 minutes, 10 minutes. If you are not getting the message in 5 minutes, they will invalidate the message.
Okay.
So you cannot able to even decrypt.
Okay. So that would be done on the data power side?
That could be done on data bus side by coding, XSLT coding or something like that, or configuration, something like that. Yeah.
Okay. Okay. So let me encrypt it now. So encrypt would be,
That's fine. That's fine. I don't need to. You executed it, right?
yeah, yeah, yeah. That's where
That's
it
fine.
came.
That's fine. No need. Okay.
Okay. Okay.
So today we will see one more certificate related action, and we will. I will explain you what about the certificates and symmetric key encryption or asymmetric key, all those things. Okay.
Okay.
Probably if you can go and see my video now, actually you should be able to try to get some. One of my colleague was taken that class. Why can't you able to try to understand now?
Um,
I
it,
can I
it,
can watch. I can watch now.
okay. Where is that?
Go to the line infotech slash the line infotech slash.
Okay.
.com/home. I think it should be in demos. Go to demos, DataPower demo. No, yeah, it's
PHP. Oh, the first one.
first and the second and third.
So first, oh no, the second and third. Okay.
Okay, watch it now. I am watching with you, so that
Okay.
if there is any doubt, you can ask me.
Okay.
Maximize it and you can see. Yeah.
Maximize it.
Yeah. Once you play it, it's YouTube, right? Once you play it and you can.
Okay.
You're hearing voice, but I could not hear the voice, but you can go through it. Okay.
Okay.
If you have any doubt, stop the video and ask me doubt from the PowerPoint. Okay.
Okay. So, Jairam, right here where he says confidentiality. So, for example, if I am using a mobile device and I want to check my TD account or using a browser to check my TD account, so I type in my ID and password for access card and password, and it sends that to the server. Is that what it means? Nobody else can see what I'm sending in the HTTP request?
It's not HTTP request. Confidentiality means how do you ensure no one other than the intended party. For example, if you're staying in the hotel or if you're staying in a public network, airport, something like that.
Mm-hmm.
Okay. So you are trying to access your DD bank account,
Mm-hmm.
but all your requests will be monitored by some hackers in
Okay.
airport. So they can route your request to that instead of TD Bank website. They can find your request and they can route it to. It's possible the hackers can route it to their website to read your username and password.
Okay.
So how we can avoid it? Even they can route it. Even if your message will reach that hacker's website, how you can able to avoid it? They cannot able to read your information. That's confidentiality. Okay, which means if the party is, if the end where you are sending, if it's a TD bank server, then it's okay. Otherwise, discard the message. That's what the confidentiality. Okay, which means you will get some certificate from the TD bank. Okay, you encrypt your message with TD bank certificate, and you invoke the TD bank server with your details to authenticate.
Okay.
Okay, so your message will be encrypted and signed by the certificate what you are using it. So the only person can, it's locked message. It's a kind of a box with locked key. It's saying, you assume that you are sending some parcel with locked numbers. Okay. So the person who's try to open the box with the correct lock number can able to open it. Otherwise, there's a bomb set in the box. They are trying to open the message with the invalid code. It will be blast. Like
Okay. Okay. Okay.
same way, you are getting the some certificate from TD bank. You are using that certificate and encrypt it, and you are sending to TD bank server. So only TD has the key. TD has the certificate where to decrypt your message to see what is the content on the message and what your request for.
Okay. So even if a hacker takes me to a third party site, they cannot do anything.
They cannot, the message will be
Garbage.
garbage.
Okay. And if even if somebody gets, if even if they get hold of TD's public key, they cannot unlock it because they would need TD's private key.
Yes, right.
Right. Okay. Because public certificate, I'm sure other people can get it too, but they won't have the.
People can get it too, right?
Yeah.
That's a public certificate. Other people can get it too. That's what most of the. That's a concept of one-way SSL and two-way SSL.
Okay.
So what's there is two. You will see that's in the upcoming presentation. There's a symmetric key encryption, asymmetric key encryption.
Okay.
So what is symmetric key encryption is both of you using the public certificate. You are using the TD's public certificate, and DD is using their public certificate to encrypt and decrypt.
Oh, so they are using mine and I'm using theirs?
No, it's let's talk about one way.
Okay. Okay.
Both of you using the same public certificate.
Okay. So that means I connect my browser connects to TD and TD gives me its public
TD gives you
certificate.
public certificate, you encrypt the message, send it to TD.
That's one way.
TD use the same certificate to decrypt the message and authenticate you.
Okay. So but they have a private key too.
Yeah, this is if they, let me explain you. So both of them have a same certificate, no private key. Then it will be a symmetric key encryption.
Okay.
What is the pros here is you don't need to spend a lot of money. So what is the concern is here is you need to spend. There is a possibility, as you said, whoever can have a public certificate can able to decrypt your message and read the information.
Right.
So the most secure way is asymmetric key encryption.
Okay.
So what is the asymmetric key encryption means? TD will have a private key as well as the SAD certificate, not the public certificate. It's a SAD certificate. It will be sharing a certificate to you, and it has the private key for the corresponding certificate. So you encrypt the message and sign the message using the SAD certificate and send it to the TD bank. So what the TD bank will do, once TD bank will receive your message, TD bank will use the private key and the SAD certificate, both combinations. So it will try to decrypt your message using the both combinations, private key as well as the SAD certificate. So your message can be able to recognize by private key as well as the SAD certificate. It's valid. It's not it's not by shared certificate and private key. It's not. It means it's invalid. So why they are using a private key and shared certificate? Because shared certificate is kind of equivalent to public certificate.
Mm-hmm.
They have to something unique, which is the private key for corresponding the shared certificate.
Mm-hmm.
So that is called the private key.
Mm-hmm.
So they will have the two combinations to encrypt your certificate. That's what you can able to see in your upcoming slides.
Okay.
Okay.
Yeah. So when I'm sending them the initial message, you said I will be signing it using the shared certificate, right?
Yes. Right.
Okay. So when do you say signed means you encrypt the whole message?
Signed, we are not yet to see the topics, and that's what we are going to see the next. How to sign the message.
Okay. Okay. I'll see it next. Okay.
Yeah.
Jairam?
Yes, sir.
Hello. Hi. So in this model, your client is your device, which is requesting information from DataPower. So
Mm-hmm.
it's the one which is, let's say, if you're a mobile banking, so my cell phone becomes the message like which is sending the message, right?
Yes.
So it then the mobile device must have a public key of the DataPower to in order to encrypt the message to be sent to the server, right?
Yes. Right. Right.
And the corresponding public private key for that public certificate will be with the DataPower.
Yes. Right.
Okay. Hello, Jairam.
Yes, sir.
Oh, sorry, I was on mute. No, what I was asking you is uh, when the message, original message, so is the hash algorithm and encrypt key logic is different, I'm assuming, right? So
Yes.
you do a hash to create a digest and then encrypt the message,
Yes,
and
right.
it's encrypted. So when it comes to the receiver, you in the receiver you get both. You get the input text plus the encrypted digest,
Yes.
and then you take the input text and then hash it to create a digest, and then you take the encrypted digest and then you decrypt that to get the original digest, and then you compare the two.
Yes. So what happens is very simple. Let me explain in a very simple way. So you are sending the message
Mhm,
and you apply some algorithm, hash algorithm,
mhm,
and you add that algorithm key,
mhm.
and the output of the algorithm is an encrypted key, which means the digest. Okay.
Sorry, say it again. Say it again slowly, please.
Okay. You are signing the message or encrypting the message.
Mhm.
Once you're done, you are using some algorithm to create a secret key, which is the digest. Okay.
So you're saying you're signing the original message.
Yes, the input text. Input text is the original message. Okay.
Let's say
So
hello
first,
world, hello world.
yes, all over. If you see the input text, the hash algorithm. Okay. The hash algorithm will create the digest, which
Okay,
means it's a security key of your entire payload. Okay.
okay, okay,
Then you put the entire payload in your header of the message. Okay.
okay,
Then you encrypt the message and encrypt the message with the digest and send it to the receiver.
okay,
So now what your receiver has is your receiver has the original input text as well as the encrypted digest on the header.
okay,
So what the receiver will do is the receiver will the receiver knows the algorithm, what algorithm you have used to encrypt to create the digest. Okay.
mhm,
So the receiver used the same algorithm on your input text message with not with the digest, only with the text, and they created a digest A, which is
mhm,
the secure the key,
mhm,
and you have the encrypted digest, which is the security key,
mhm.
and decrypt it and validate both digest A, which generated by my algorithm, and what I am receiving from your side. It's both are same. If both are same, your message has not been modified and hacked anywhere in the middle.
Okay.
If
So yeah, so
if somebody change your message in the middle, hacking and changing your message, they can able to change your input text, but they cannot change your encrypted digest. In that case, your input text is changed, the digest A will differ, digest B will differ, which means somebody will hack your message.
mhm.
You got it?
Okay. So I just want to go to our the message we encrypted here, right? So let's apply this logic here. So you're saying that this original message, let's say we had this weather, right? So we had this message, this client side, get weather, whatever, here 9020, right?
That's fine. Okay.
So this is our input message, let's say.
Okay.
So, and so you're saying in the header, you will have the actual algorithm key. Is
Yes.
that so? Let me go back here, your
Okay. You can
diagram.
you can see the chipper value here.
Where?
Go to SOAP UI.
How do you go there? Let me exit from here. Yeah,
I think the chipper value, chipper data, I don't know.
encryption method algorithm. So here is the encryption algorithm, right?
Yes, encryption algorithm, encoding type. So
But
this is
here
the
you,
this is the header. Actually, What algorithm they are using? XML.
Triple DES CBC. Look at this encryption method. Cipher data Civ.
Yes, cyber data chip. Yes.
Okay.
So the below one is your message. The cyber value is your chipper value is your message, actual message. The top
Okay.
chipper value is your encrypted message with algorithm.
Where is that? Top means this guy?
You have a one more chipper value, right? On the
In
top.
here.
Yeah.
Okay, so there are two messages here. This is my input, I think, and this is my input. You're saying there are two inputs, right?
Yeah. This is the digest which is created by input.
Okay, so that means original message is never sent. This diagram, this was little confusing. So if I look at
Hold on. This is not happening what we are doing right now. Okay.
mhm.
It's a totally different topic. We are not applied any algorithm, something like that.
Right.
There is a different way to do that. We will look into the advanced topics. Okay.
Okay, so here you're saying the input text. So I had a, let's say input text here. In this case, you had input text, hello world. So hello world. So this hash. So the hello world is sent as is from client to the server.
Yes.
Okay, and then as part of the header, you have the hash algorithm.
Yes.
And in the header, and then where is this digest? Digest is the header, or digest is the actual body of the message?
The digest is the part of the message body, message header.
Message header. Okay, so that means there is a copy of the input message in
Yeah,
the header.
exactly. The hello world.
Okay, hello world encrypted using or sorry, hello world in the hashed value.
Yes.
In the okay, and where is this encrypt comes in? So this encrypt is encrypting the body as well now.
The total message. Yeah, body. Yeah.
So that means this hello world. So the hello world is fully encrypted now.
Yes.
Okay, and that's being sent to the server, and the server now uh, takes the hello world which was encrypted.
No, it
Okay,
is not encrypted.
but here we encrypted it, right?
Where the arrow comes from? See that.
Oh, so that means this arrow came
There is two
straight to
inputs.
the.
There is two inputs you are sending to the receiver. One is your input text. One
Okay.
is the encrypted digest. There is a two different input you are sending to the receiver.
Okay, so the top line here is you take the hello world, hash it, create a digest, and then encrypt the header only, not the body. Or
Yes.
maybe okay, not the body, just the you send the encrypted digest.
The digest is nothing but the encrypted body.
Sorry, digest is the encrypted body. Oh, I see. Okay.
Sorry, the algorithm applied and the security key. The I will explain the topic more. Okay.
Okay. So that means it's sending that means it's sending the algorithm also as part of the message.
No algorithm. Algorithm will knows by the server.
Server knows what algorithm. Okay, so that means the digest is really the header. In the header, you are encrypting it and sending it, and then the receiver also gets the real input, which is hello world.
Yes.
And then it okay. So if a hacker can easily change hello world here
Hello,
because
hacker can easily change your hello world, not your digest.
not your digest, right? Because then you encrypt that digest, you send it to through decryption, and you get the digest, real digest, right? And
Yes.
then you do your algorithm with the real input, and then you calculate. I see. Okay. Okay. It's bit it takes a while to put it in your head, right? So
Yes.
okay. Should I continue the message video? It's 2 minutes left.
Yeah, please go and complete it.
Okay. Okay, I think it's finished this one. I
Yeah, second
started.
one is we already saw that by exercise, I think.
Okay, so second one. Okay,
You can take on your free time actually.
okay, I will. Okay, so that means really, so the example he said was actually very good. So let's say if you have 10 mobile client and you will distribute the data power in this case will distribute the public certificate or shared certificate to all the 10 clients, right? And
Yes.
then the 10 clients will start encrypting all the messages sent to the server, or in this case, the data power, and that's how they will make sure the encryption is happening, right?
Yes.
Right. And what is so cryptography? What is the difference between cryptography and SSL? Same thing?
Cryptography is the concept. SSL
Okay.
is the certificate name.
Oh,
SSL,
it
yeah.
okay. And TLS is the same thing, right?
TLS is something different. They are calling us new things. TLS is
It's a new thing.
yeah.
But same idea. It's built on cryptography concept.
Yes, yes.
Okay. Okay. So coming back to that TD example you were saying, so that means if I have a mobile device and I'm using a mobile app to communicate with the server, and if it's sending some sort of a JSON or instead of XML, I'm not sure if mobile talks XML. I think it probably talks.
JSON, yeah.
Yeah. So that means, can you encrypt JSON as well?
Yeah.
Oh, okay. So there is no limitation of. Usually XML is more like you. With the example we have, SOAP is nicely, you have the header and then footer, not footer, but header, the body, and you can encrypt and everything. So you're saying JSON also you can encrypt the whole thing.
Yes.
Okay. And then same thing on the data power, it will encrypt or decrypt or whatever using the key, it will decrypt and then call the appropriate service on the client side, on the server side, right?
Yes.
Okay.
Okay. We'll see. Move on to the next topic.
Okay.
We are recording these videos, right?
Yeah. Yeah.
Okay. So go to that data power again. So now we are going to sign the message.
Okay. You have to tell me how to. I know you told me about the what was that
First, go to domain 2.
domain two. No, for copying the video for you, right? I wanted to. You
That's
told me.
fine. That's fine.
Okay.
Once we are end of the course, you can upload all the videos. That's fine.
Yeah. Yeah, yeah. Domain two, right? Domain two.
Yes. go to the weather web service, something like that. Okay, let's do this in a separate exercise. Okay, go and create a new XML firewall.
Okay. Or domain 2 or domain 1, doesn't matter.
Domain 2. Always do the exercise on domain 2 during
Okay.
the class. Domain 1 is your own exercise. Okay.
Okay. So domain 2.
Create a firewall called
Is there a name you were suggesting? Or?
yeah. Create a name called Symmetric Sign underscore sign. You can have symmetric underscore sign.
It allows you to put underscore,
Yeah.
no space.
Yeah.
I think. Okay.
Yeah. Which means we are going to sign the message using symmetric key.
Okay.
Let's
And
see the asymmetric key as well. Okay.
okay. Static or loopback?
It's a loopback. Let's have no. We just see the data power how it's working, right?
Okay. Send it back. Yeah.
Yeah.
This one, when I was creating, it said 00, but I gave a physical address. It's okay, right?
Leave it 00.
Okay.
So what happens if you give the physical? Once you export your code into another data power device, the IP will vary.
Oh.
Okay. So normally what people will do, they will leave it as 0.0.0, but they will configure, they will open the firewall for only for the input IP. So even though you said 0.0.0, this service can be accessible by any out of any 4 LAN port. But if you open the firewall for the service providers on the one particular IP, they cannot access the firewall other than the assigned IP. Okay, you got it.
No, I'm little. No, I didn't get it. Please. Can
So
you?
which means 0.0.0.0 means what is actually it's really means in 151.152 on your IP 192.168.2.151, right?
Yeah.
Your data port has 4 IP 151, 152, 153, 154.
Yeah.
So through all the 4 IPs can able to access this service.
Mm-hmm.
If you really want to user to utilize only one port, then actually the networking team what they will do is they will open firewall to call only 152, 192, 162, 150.2.
Oh. Okay.
So there is no firewall for any other LAN port. So
Okay.
the service can be able to invoke by only one LAN port, but you don't need to change it here. Okay.
Oh, okay. So you always keep it 0.
Yes.
Okay.
But the yeah 0 should be fine. But let's it's whenever the more example comes, you actually knows.
Okay. So in the real world, you will put the you would develop the you would not put zeros. You would put whatever the firewall your
Yeah, what
network guy.
in real world what we will do is we will create the alias for each LAN port and
Mm-hmm.
we will assign the alias. If you
The
assign the alias, it will point the alias, but all the environment has the same alias names.
okay.
But the IP will be different on the configuration side, so it automatically take care.
Okay. So you may say Anup 1
No,
alias.
I can say inbound. I can say outbound. Is the alias.
Oh, okay. So inbound, outbound, blah blah blah, and inbound is actually bound to a particular IP.
Particular IP, yes.
Oh, okay. So that way yeah, that way you are not hard coding the the IP in here. Otherwise, you are stuck with it, right?
Right.
I see.
Well, let's create alias first. Why can't you go to the LAN network
LAN network.
or
Okay.
type alias? Not cell alias. It seems to be.
Network alias
Yeah, it seems to be type network.
interface.
Yeah. No, because you are in domain. You are in domain 2. You need to switch back to default domain to create alias.
Okay.
Now type alias.
Host alias.
Yes. Add
Ah,
type management mgmt capital letter.
MGM,
Type capital letter mgmt
MGMT
and the comments say that it's a management port, management IP.
management space IP
And the management IP, you know that what is the management IP is 192.168.2 dot
151, I think.
16. Yeah, type it.
192.168.2.151. No need of port number, right?
No.
Okay. Apply.
Yes. Create the same way for inbound, outbound, and use the fourth one for logging on and SLM.
Okay.
Again, click the host alias. Yep.
Okay. Add. Call it inbound and inbound IP address is 192.168.2.152. Apply. Save. Okay, so I can't create another one here, right? I have to go back to that window.
Left hand
Cancel.
side host alias is already selected. You can click on that again.
Oh, okay. Okay. Add. We haven't used outbound yet, but it's okay, I guess. Outbound 192.168.2.153, I think.
No, that is the IP.
It's here. And it's outbound. And save. 151, 152, 153, 154. In WebSphere, we call it virtual host, right? You can create many virtual hosts. I think the same idea here. I
Yeah.
think, right? This is logging.
Yes.
This is logging. 192.168. 2.154.
Now go to your firewall.
Oh, where
Domain
is
2.
it?
Change it to domain 2.
How old is your kid?
I have two kids, 4 and 1.
Oh, okay. That's you're a young guy, man. Dummy, symmetric. I know I've been through boy, girl, or
Yeah, the elder one is girl, the younger one is boy.
oh, boys are more trouble because I have a older boy and a younger girl,
Mm-hmm.
and yeah,
So
boy
select
was
alias on the local IP.
it's here, right?
Yes.
It's so it's already mapped into inbound.
You are a foreign.
And save.
Make all changes in after some time. Okay, in all services.
I will do that.
Yeah, because I want to import your whole exercise into the real box,
Okay.
the live box, right?
Right. Okay. So that's okay. You were saying okay. So I have to now go into symmetric now, right? Symmetric firewalls. So
Go to the policy. The request
policy.
type, make it as a XML or SOAP, something like that. That's fine. Go to, we'll find apply finally. Okay.
Okay. Okay. Okay. So now I go to sorry where?
Open the policy.
Policy. Okay. All the action is in the policy, I find, right? A lot of things in the policy. Okay.
Yeah. So now it's a default, it's star, right?
Default, you're right, it's star.
Check. Okay. Drag and drop sign action. Now you are going to sign the message
Okay.
and encrypt it. Okay.
Okay. So let's see what is in here. Okay. So I need to give the input and signing key, primary key, right?
There's two things. Now we said how we are going to sign it.
Right.
The signing algorithm is going to be RSA algorithm.
Oh, these are all the
So use asymmetric key is on. Okay. Put it
on.
off. We are going to do a symmetric key, right? Turn it off.
Okay. Off.
No, you're turning off asynchronous. We need to turn it off asymmetric key.
It's hard to see which one is this. So this is on off for symmetric.
Yeah, off.
Okay.
Now your key and certificates are gone.
Oh, okay.
So now it's having hatchmark sign algorithm. It's coming.
Hmm.
So the you have only asymmetric type key. Drop down. Let's see what is there. Okay, that's fine. Leave it as it is. You need to select the certificate now.
Okay.
I think
Signing algorithm.
go to advanced. Let's see if there is any option to select certificate.
Here, XSL.
No, this is XSL stale sheet. So symmetric key is symmetric. Where is the certificate? I am wondering.
Action type is sign. Wouldn't it be somewhere in the local? Like here?
No, it's a stale sheet, not a stale sheet. I am talking about.
Oh. Oh, it should be in my profile, right? Somewhere in the so I have to create it. So I can create it using a builder or something.
Hold on. It's
It should be in the builder. Or I have to go and create a profile.
yeah. There should be an option to specify the certificate. Which certificate we are going to use for symmetric.
Asymmetric is use asymmetric is off. Signing symmetric key type maybe, right? Use a key in security context. Something here. Symmetric key type. There is some logic here probably. Or it's in the
Select drop down. What are the options are on?
use a random key and encrypt it for the recipient. No, that should be good one. Use a random key and encrypt it for the recipient. Use an existing token.
Use the existing token, select it. Let's see what's happening.
Use an existing DKT token.
Yes, select it. Let's see.
Okay. Name of the base DKT to derive.
It's not one. Go and select some other option.
I think this is good.
No, not random key. Hold on, hold on. We need to verify that.
Oh,
Oh, yeah, correct. Select the Anup. That is the certificate.
that's Anup is the private key.
No, the Anup is the certificate. CSR. Public certificate.
And what is this one?
That is the credential with the private key and this.
Okay, something else.
Yeah.
Okay, so Anup, right?
Yes.
Oh, okay. Okay, then done. Output I don't have to worry about.
No need
Done.
to worry. Yeah, done.
Okay. So once I'm done,
Now
then
see.
sign. Okay, then I put encrypt here.
No. Just sign it. It will be once you sign, it will be automatically encrypted.
Okay, then I
Let's see. First sign it. First sign it and test it. Then we will do it.
have already put it. So
Yeah, apply policy and test it.
Okay. By policy and so sign it means you encrypt it, right? When you have whenever
What's happening? Let's see what's happening.
Okay. So do I have to do a loop back or something here? No, this is already a loop back.
Go to request one. Click on request one, something like that. Okay. Don't need to clone. Don't need to double click. Add the new endpoint, which is 2053, right?
Mm-hmm.
Click add a new endpoint. If you don't add a new endpoint, it will be not available next time.
Okay.
And you can say sign. Instead of Anup, you can say sign. It's a star. Anyway, it will accept anything, but
And HTTPS. No HTTPS yet because we didn't.
yes, yeah.
And I'll say okay.
It's a 2053. Can you verify that?
2053.
Oh, okay. Because of the loopback, it's not going into the policy.
I can turn the probe on.
No. It should be go into the policy, right? I don't know.
So it is coming in. Something is coming in.
Click the mirror icon. Let's see what's happening. It's going into the policy or not. Yeah, it's going into the policy. Click the second one, the signed one.
Header.
Click the mirror icon after the sign symbol. Yeah.
This one? Oh, after this one.
Yeah.
So it's not signing it, right?
It's sign. I think it's signing, but
It's looking same though. Oh, do I have to do something to the result? Because I haven't.
no, it's a pipe, right? That's
Right.
okay.
Maybe I have to connect the pipe somewhere. Let me check the policy here.
So what is the output of the sign action? See?
Yeah, see, it's a DP bar.
Okay, that's fine. What is the input for the result action?
Input.
Oh, it's not input. It should be a DPWare, right?
Yeah, but
Well, let's see. Go and check.
but here I never selected the XSL. Why it is saying XSL? I didn't apply any XSL.
No, it's by default. It's having some XSL.
Okay, so that's okay then. So then I have to give the output as dpvar
Yes,
as a routing, right?
not routing. The result action.
Result action can take var.
Not well, yeah. Try to do it. Let's see.
Okay. So right now it's taking input. So whatever input is passing output. So you're saying if I change to dpvar, then let's see
Give
what
done.
happens.
If not, it will give you. If not, it will throw you error.
I see. Okay. This I like the probe, right? Because you can do so much debugging, and it tells you where it can. Okay.
So because you are passing DPWare, it's not giving you anything.
Hmm.
So actually, DPWare is something. It's happening inside. It's signing.
Is it possible that I can put the route and then route it back?
No. Everything what we are doing, but let's do asymmetric. Okay, as of now.
Okay. Okay.
Create a new firewall saying asymmetric is signed.
Okay.
Let's correct this tomorrow. Okay.
Yeah.
It's
And
one yes, I think.
huh?
The spelling one yes, not two yes, I think.
Okay. Asymmetric. I'll just call it FW so we know what I'm creating, right? Forward sign. And static
Look back.
loopback. Alias is inbound is good. 2054 commit. Save. Okay, go back into XML and click on asymmetric and policy.
Drag and
Sign.
drop drive sign. Now double click it.
Okay.
Now don't change anything. Come down. No. Let it be. Don't change anything. Come down. And key. Select the key.
It's already on.
And that's fine. Select the key. Key is key is Anup key. Select the Anup key.
Okay.
No. Key is something called you have a ID credential Anup. Yeah, select that one. Certificate. Anup certificate. CERT.
There is no.
Go to drop down. You can see Anup underscore CERT.
Okay.
This is the private key and SAT certificate. Okay.
Self-signed certificate.
Yes, right.
Okay.
Give done. Okay, apply policy. Close window. And in request type, change the request type into SOAP, something like that. Now apply. Save config. Now try it with 2054.
Ah, wow. So that's all the garbage it's spitting out, right?
Yeah.
Okay.
Let's
So
fix what is wrong with the symmetric key tomorrow, okay?
yeah. Okay. But
You
see,
can
this is
see the
nice.
digest method and digest value here.
So where is the okay? So the body here is my body, right? So
Your body is here. The body is the input text. That's
that
what I
is the real
explained.
one. That is the real. It didn't change that one.
That is the real one, and you have a signature value, right?
Where is that? I don't see it.
Go top,
Let
key info,
me
above key info, you can see the signature value.
signature. Ah, here signature value.
Yeah,
What is this? What is this?
I think that's your digest.
And the digest is nothing but hashed value of this our this method, right?
Yes.
This body.
Yeah. You can see the two algorithms up. There is a two algorithms applied. One algorithm is algorithm method, and the reference URI is something like that. You have a two digest value, digest method, and two different digest method and two different digest value, right?
Let me
So
see.
if you're doing asymmetric key, these actions will be executed. This input will be again converted into digest and match the corresponding digest here.
Okay, so can you? So this is my header. The header is everything between SOAP header, right?
Yeah. So what's happening is once you send this message to bank, once you send the message to the destination,
Mm.
it will take
TD
only
Bank.
the body. It will take only the body
Mm.
and do the try to create the same header using the private key.
As
Okay.
this.
Yeah. So
So
all the header informations are available in your message should match.
okay, so it will take. Let's say in the body, I have my credit card number and my password.
Mm.
So, so
If somebody changed that, then the value will not match on the header.
So okay, so they made a copy of this thing inside this whole damn thing, right? So
Yes.
it's like a copy of everything here, and on the destination they take everything in this thing in the body and and create the using the algorithm they create the same logic as the header, and then they compare the two.
Yes. Right.
Okay, but that means the hacker knows everything in the body because this is not encrypted. This thing is not encrypted. They see the real message.
Okay, body is not encrypted, but all the headers value they don't know what's the idea.
Well, if my credit card is here, then I'm screwed, right? They know my what is my user ID password.
You can encrypt it. That you can encrypt it. Still, we are not encrypting it.
Okay, so you can encrypt it if you want. So then you have a double encryption. So you have encryption and you have signed.
Encryption. First is the sign and encryption.
So that means sign anything you sign, it actually attacks the header. Like
Yes.
means it puts everything, do all the magic and puts it in the header. If you encrypt it, then it will encrypt the body as well.
Yes.
Okay,
Right.
I see. So then on the destination, you will first have to decrypt it to get the real message,
Yes.
and then go into the header and then apply the algorithm
And
and
verify
then do the decryption. Wow.
it. Yep.
Sorry?
And verify it.
And then verify it. So it's like a double protection.
Yes. Now
Okay.
go and apply the encrypt as well. You can see what you can do.
Encrypt. Oh, yes, that's what I was thinking. Okay, I'm gonna apply that. So if I go into So I have the sign right after, and I drop the encrypt. Okay, then in the encrypt, I have to remember what did I do. Okay, so in the encrypt, I
Don't
took
select
the.
anything. Leave it everything as it is. Don't change. Don't confuse. It's a pipe.
Okay, but I have to input
No.
something
It's a
in.
pipe. It's a pipe. Don't
It's a.
don't touch anything.
Okay, I won't touch anything. Okay,
Recipient
so
certificate. Select your certificate. Anup.
where is that? Recipient, right?
Yeah.
So Anup is the certificate. Oh no, the other one.
Right. You are doing right. You are doing
Okay,
right.
okay. So Anup is this thing. Then I do done, and I apply the policy, and I have to turn on what do you call this guy also, right? Proxy.
No need. No need. No need.
If I don't turn, okay. If you say okay, because okay, I'm not sending any key. So you don't have to have HTTPS to do the encryption. That's what you're saying,
Yeah.
right? Okay. Now I run this. Let's see what happens. Ah, so now this is all encrypted. Body is encrypted and the header is encrypted. So on the destination side, then I have to first decrypt it,
And
then, sorry,
verify it.
and then verify it. So the opposite of encryption is decryption, and opposite of sign is verify.
Verify. Yes.
Okay, that's how it works, like
Yes.
parallel. Okay.
So we will see the reverse action tomorrow. It's little bit tricky work.
Okay.
It's not a very easy one because we can copy and paste it on left hand side. We cannot do that
Yeah.
because that's expiration time on that one.
Of
Created
course.
and expires. If you see
Okay.
timestamp value, can you see the timestamp value?
Where is it?
Go up.
Oh, right here.
Yeah. So it's created on 59, 20, something like that.
2059.
2059 and it expires
Five. 5
04.
minutes. 5 minutes.
I think it's 5 minutes. But even though if you copy and paste it, it won't work because if you copy and paste it, which means you're modifying the message.
Okay.
You got it? What I'm saying?
Okay. So if I copy and paste it, it will think that somebody changed the header.
Yes, somebody changed the header.
Okay.
So
So I can't change.
we cannot validate like this. We have to pass the message by the way. Okay.
Mm-hmm. Okay.
Let's see that tomorrow. Okay.
Okay. Sounds good.
Okay. So how do you think so far on the SSL part?
It's exciting. It's I mean I like it. It's I mean this is, mind you, this is all new thing for me, but that the fact that I can see the message being encrypted and decrypted, that because when I'm writing web services, I don't know how we just give our whistle and they do it, right? They are probably doing something this magic, right? The
But the well, nothing. But you have to write the code in that your language. But here
Mhm.
you don't need to write the code. That's a
Yeah, that's the beauty part. And I think that is why data power is, like you said, the first day is so getting so popular in different shops, because if you write a JSON or REST service or SOAP service, you don't have to worry about how the hell I had to secure it, right?
yes.
Because if data power is not there, then the developer has to think
Yes.
about security, right?
Yes.
And you know, if developer starts to worry about security, there is a problem in that environment, right? Then anybody definitely that service will be hacked, because developer is thinking about security. They should not be thinking about security, right?
Yes.
Data power should be worried about security.
Yes.
Okay, this is good thing, man.
Okay. We'll
Yep.
continue tomorrow.
Okay, have a good night, Jaram.
Yeah. Good night. See you.
Take care.
Try